Hello everyone, welcome to my YouTube channel Backend Community Lab. So today I am sharing a few things on the GCP, what is physical server, what is Google Compute Engine and virtual machine. So in this series we are going to learn GCP in very logical and a practical way. So let's start. So before going to jump in physical server, first we need to understand why do company need the physical server or the server. So here physical server, physical machine are the same thing. Why do company need servers? Every organization runs application like banking app, food delivery app, WhatsApp, Facebook. So to run these application we need server where we can deploy these app and this can run 24 by 7. That's why company need the server. So let's understand what is the physical server or server. A physical server is nothing but a powerful computer, just like your laptop or desktop. So in your laptop and desktop, having the below component CPU, RAM, disk, network. Same way in physical server, we are having these component. Physical server also have CPU, RAM, disk, network. So what is the main difference between these server? What is the main difference between your laptop and the physical server? The main difference is these are very powerful. So the next question arises, what we are doing in a physical server or laptop and desktop? So in laptop and desktop, we can install OS, we can install Java, we can run database, we can deploy app. So same thing organization is doing in a their physical server. We can also install OS in physical server, install Java, we can run database, we can deploy application in our physical server. Before cloud, company are used to buy these physical server to do these operations. So what problem we are facing before the cloud? Before the cloud, every organization was buying these physical server. And these physical server are real metal chips, just like your laptop and desktop having a lot of chips. So same way, we are having these component into the physical server. So each organization are buying these physical server. So if organization is very big, then they need a lot of physical servers. Let's understand in this way to run our laptop and desktop what we need. We having our laptop and desktop. First we need space, we need electricity, we need cooling. So laptop and desktop having inbuilt fan, we need maintenance. If any part is failing, we have to replace that part. Same way, these applicable with the physical servers. Physical server need space, electricity, cooling, maintenance. So think about if organization is very big, then they are running a lot of application. If they are running a lot of application, to run those application, they need a lot of server. If they need a lot of server, then they need the space as well to store those servers. They need more electricity, they need more cooling and the more maintenance. Earlier, where they are storing this server, so they are having one big room where they are having some racks. In each racks, they are storing the server. So these are the servers. Let's think about if anything is failing in this server, so they have to replace that part. If they are replacing, that needs some cost. So they have to manage these things at their own. And these rooms are called as a data centers. So this room needs some security as well. Organization has to do the cable management, cooling, cleaning, firmware update. So they have to do these kind of things to run these server properly. Otherwise, if any server is failing, then in this case, that application will go down, and that's having some impact on the customer side or having some cost impact. So let's understand what maintenance means here. There's a few things that each organization is doing to run their server properly. So each organization has to do these things by their own. So maintenance having a lot of cost. What they are doing in a maintenance. So first thing is hardware diagnostic. The organization is running tests to check component health like disk, memory, CPU and identify early sign of failure. The second thing they are doing cleaning. Cleaning means removing dust, dirt that can cause server heating. So if server is heating, then they can fail. Next thing they are doing component replacement. So if any component of any server is failing, they have run the diagnostic, they have found this part is going to fail, so they have to replace that part. If they are going to replace that part, that's having some cost. They have to buy that thing, that part. They are doing firmware update. So in firmware update, they are installing crucial update to the server for the security or performance reason. Next thing they are doing environment check. So in environment check, they are monitoring the temperature and airflow within racks to prevent the overheating. So next thing is physical security. So in physical security, like checking server racks, keys, and access control for the physical tampering. Then cable management. So they need to organize the cable for better airflow. Before the cloud, they are doing these kind of maintenance for their data centers. So maintenance was big issue for each organization because it's include a lot of cost. So this is one part where they are facing a lot of challenges. So suppose any startup is there, they have to run or they have to build some MVP. So for that as well, they have to maintain these things for their servers. The next thing they are facing on a scaling side. Scaling means increasing and decreasing system capacity so that your application can handle more user, more traffic or more data without slowing down or crashing. So before scaling, let's understand the basic concept of the server. So we are having one server that having one CPU, RAM 16 GB and it's having disk 1 TB SSD. So our application is deployed in this server. So each server having some capacity, like in a particular time frame, they can handle only certain requests. So if we assume, or let's take an example, this server with this configuration can handle only 50 requests per second. But what if load is increasing from 50 RPS to 100 RPS in this application? So why the load will increase? So let's take an example. There is a fest season, and in this festival season, this application having some offers. If they are providing a good offer, then lot of user or lot of customer will increase on this application. But this server can handle only 50 requests per second. Then how it is going to handle this 100 requests per second? If load will increase 50 to 100, then in this case this server will fail or crash. So how the organization was handling this situation? So there is a two way we or organization can handle this situation. One, we can buy more resources. We can make this server as a big machine. Earlier we are having one CPU, now make it a dual core. RAM 16 GB, disk 3 TB SSD. Now this machine is more powerful and this can handle 100 requests per second. I'm just taking an example. An app is also deployed in this machine. So what we have to do, what organization has to do, they have to buy a more resource. They have to make this server as a big server or big machine. They have to deploy this application on this server. Now they are able to handle 100 requests per second. So what they are doing, They are making one machine more powerful. They are buying more resources. So this concept or this scaling is called as a vertical scaling. So suppose in future this app is more popular. So then again number of requests will increase. So suppose if number of requests is increasing 100 to 200 per second, then again this server is going to fail or crash. This time what they will do? They will do again the similar thing, like they will increase the server capacity or they will buy more resource, RAM 6, RAM 32 GB, disk 5 TB. So this is more powerful machine. Now this machine can handle 200 requests per second. And whenever they are purchasing the app or more resources, they are having some downtime. So they have to down this application. They have to increase the resources, and they have to deploy this app. So in this process, there is a downtime on the application. So there's a other way to handle this situation where load is increasing. So what is the other way to handle? So we are having one server with configuration, one CPU, 8 GB RAM, disk 1 TB. So what we can do, we can we can buy more server with the same configuration. That's having the one CPU, RAM is 8 GB, then disk is 1 TB with the same configuration, and we have to deploy this application into the both the server. If we are deploying this application in both server, when request is coming, how to decide in which server this request will go? So in this scenario, we have to add the load balancer here. So we have to add load balancer here that can distribute the load among these server. So this is the distributed system, and this scaling is called as the horizontal scaling. This scaling having there's a own set of challenges, like how they have managing the transaction. Before the cloud, each organization is going with either vertical scaling or horizontal scaling. But both the scaling is very tough to manage. And also vertical scaling have some downtime. So there can be one situation when we increase the resource and we make this server to handle 200 requests per second. There's a chance one competitor app in industry, and due to this load is less. Earlier we are getting 200 rps per second, now we are getting 75 rps. In this situation our resources are going to waste. There's a no need of this these kind of big machines. Again, if they have to decrease this machine, there will be some downtime, and the resource occupied for this application that will release, and we can use for them for the another application. What about here? If load is less here, then we have to remove this server, and this server can be used for the another application. But managing this was very tough. So these are the problem that we are facing or organization facing before the cloud. So how cloud is providing solution for this problem? Cloud is providing solution here. Instead of buying these server, they can rent and pay based on their users. So they can focus on business instead of the managing these servers and scaling, load balancing, and all the maintenance part that they are doing by their own. So Google is one of the cloud service provider. We know that platform as a Google Cloud Platform. So Google having the data center across the world. And we already know in each data center we are having the rack and the physical machines. So same way Google is also having the racks and the physical machine. all same thing in data centers like physical machine, cables, racks. So let's assume this is a physical machine. So this physical machine will be also same as a or laptop and desktop that we have already talked about. It's having the CPU, RAM, disk, network. But as a user, we are not going to directly touch these physical server. So now the next question is arise how we are going to do the set of operation that we are doing in that organization is doing in their own data centers or their physical servers like installing OS, Java, running the database, deploy the application. So how we are going to perform in these physical server. So this is possible using a very good concept that is called a virtualization and one service GCE, Google Compute Engine. So let's understand about the virtualization and Google Compute Engine. What is virtualization? A virtualization is a software-based simulation of a physical server. So one physical server can be run as a multiple virtual machine. So Google having the data center. In data center we are having the physical server. In physical each physical server we are having the following component like CPU, RAM, disk, network. So one physical server can be run as a multiple virtual machine. Each virtual machine has their own component like CPU, RAM, disk, network. Here we can do our operation like we are doing in physical server, installing the OS, installing and running the Java database and deploy the app. We can do the setup operation that we are doing in our physical server in virtual machine. Each virtual machine having their own CPU, RAM, disk and network, and we can perform these operations in each virtual machine. And one physical server can be run as a multiple virtual machine. So it's a software based simulation of the physical hardware. How this is possible? So this is possible called one of the service GCE. So let's understand about the Google Compute Engine. Google Compute Engine is a service. Using this service, we can create virtual machine. We can start, stop, and restart the virtual machine. We can attach network on these VM. We can do load balancing here, and we can also do scaling. So these operation we can perform using this service that is called GC. So let me draw the complete picture. So we are having the physical server, each physical server having the CPU, RAM, disk and network. Using this service called GC, we can create multiple VM on this physical server, and each physical server having their own set of CPU, RAM, disk and network where we can install OS, Java, database and deploy. So this is the complete picture how Google Compute Engine is working. Please do a like and subscribe to support my channel. Thank you for watching.